Hey guys, what's up? Today we'll be covering pile foundations. Pile foundations play a critical role in modern construction, particularly for heavy structures on weak or compressible soils. In this lecture, we'll discuss their purpose, types, design considerations, and installation methods. Let's get started. To understand pile foundations, we need to start with the basics. Foundations in general are the part of a structure that transfers loads to the ground. Now, most structures can rely on shallow foundations, where loads are spread near the surface. But what happens if the surface soils are too weak to carry the load? This is where pile foundations come in. Pile foundations are categorized as deep foundations. They work by transferring loads to deeper, stronger soil or rock layers. Imagine them as long columns, usually vertical, embedded into the ground. These piles bypass the weaker soil and anchor into a stable layer beneath. Their primary job? To ensure stability and safety, even under heavy loads and challenging conditions. There are various types of pile foundations, and we can classify them based on material and how they transfer loads. Concrete piles are among the most common materials. These can either be precast, which means they are manufactured off-site and transported to the construction site, or cast in place, where the pile is formed directly in the ground. Concrete piles are known for their versatility and durability, making them suitable for various projects. On the other hand, steel piles are ideal for applications requiring deep penetration and high strength. They are often used in marine environments where durability and resistance to harsh conditions are essential. Timber piles, although less commonly used today, remain a cost-effective option for lighter loads and temporary structures, particularly in specific environments where their environmental impact is minimal. There are two main mechanisms for load transfer. End-bearing piles transfer the load directly to a strong layer of soil or rock at their tip, much like a column resting on a stable base. In contrast, friction piles rely on the interaction between the pile's surface and the surrounding soil to distribute loads along the shaft. Both mechanisms have unique applications, and the choice depends on site-specific conditions. Pile foundations are indispensable in modern construction for several reasons. One key advantage is their ability to bypass weak surface soils, transferring loads to deeper, stronger layers. This makes them a reliable choice in sites where traditional shallow foundations are insufficient. Additionally, pile foundations excel at handling not just heavy vertical loads, but also lateral forces, such as those caused by wind or seismic activity. Their adaptability is another significant benefit, allowing them to be used for both land-based structures like skyscrapers and water-based projects such as bridges and offshore platforms. These qualities make pile foundations a go-to solution for many complex engineering challenges. Designing a pile foundation requires careful consideration of multiple factors to ensure safety, efficiency, and cost-effectiveness. The properties of the soil play a critical role. Engineers need detailed geotechnical investigations to understand the soil's strength, stiffness, and layering, as these characteristics dictate the pile's type, length, and capacity. Another important aspect is the load requirements of the structure. Pile foundations must be designed to handle vertical loads, lateral forces, and, in some cases, dynamic loads such as vibrations from machinery or traffic. Environmental conditions also influence design choices. For example, engineers must consider the potential for corrosion in coastal areas, while lateral stability becomes a primary concern in seismic zones. Balancing these factors is essential to creating a practical and reliable design. The method used to install pile foundations depends mainly on the project requirements and site conditions. Driven piles, for instance, are prefabricated and then driven into the ground using a pile driver. This method is fast and highly effective for cohesionless soils or projects requiring high-capacity foundations. However, the noise and vibrations associated with pile driving can be a concern, particularly in urban environments. Board piles, on the other hand, are created by drilling a hole into the ground and then filling it with concrete to form the pile. This method is quieter and more controlled, making it suitable for areas where minimizing noise and vibrations is essential. Each method has its advantages and limitations, but proper installation is critical to achieving the desired load carrying capacity and long-term performance of the foundation. Pile foundations are used in a wide range of applications, often in projects where stability is non-negotiable. For example, in coastal cities, skyscrapers frequently rely on end-bearing piles to reach stable bedrock beneath layers of loose sand. Bridges over rivers often use steel piles driven deep into the riverbed to resist both vertical loads and lateral forces, ensuring stability even under dynamic conditions like strong currents. Offshore oil platforms too rely on pile foundations for stability against waves and environmental forces. These real-world examples illustrate the versatility and importance of pile foundations in solving complex engineering problems. To wrap up, pile foundations are an essential solution for transferring structural loads to stable layers, especially in challenging soil conditions. We've explored their types, advantages, design considerations, and installation methods, along with some real-world applications. If you found this discussion insightful, consider subscribing to more lectures on civil and structural engineering topics. Feel free to leave your questions or suggestions in the comments. Thanks for watching, and I'll see you in the next lecture.